Alright, so we have some comparisons to graphing linear equations. So there's some similarities and some differences. Both are best graphed using slope-intercept form. And we all know that that's y equals mx plus b. We've been studying that for a while. M is the slope, and b is the y-intercept. And then you're going to graph, start the line on the y-intercept, and then you use the slope to create some more points. Same thing that we've been doing for a while. Some differences. Inequalities do not always have a full line. If they have the or equal to, then it is going to be a solid line. So if you have something greater than or equal to or less than or equal to, it'll be a solid line. Without the or equal to, it's a dashed line. So if you have just less than or just greater than, it'll be a dashed line. Inequalities have shading on the graph. Less than, we shade below the line, and greater than, we shade above the line. All right, so if I look at my examples here, I have y is greater than or equal to 1/2 x minus 2. We're going to determine, or sorry, just greater than. We're going to determine the type of line and the direction of the shading. So since this is just greater than, it's going to be a dashed line. And since it's greater, it's going to be shaded above the line. This one right here, we have a less than or equal to, so that's going to be a solid line. And since we have less than or equal to, it's going to be below. These next two examples are not in slope-intercept form, so we have to go ahead and rearrange that. So I have 2x plus 5y is less than negative 20. So to rearrange, I'm going to subtract 2x from both sides. That leaves me with 5y is less than negative 2x minus 20. And divide everything by 5. And I have y is less than negative 2/5 x minus 20 divided by 5 is 4. So it's strictly less than, meaning I'm going to have a dashed line. And since it's less than, be below. The shading will be below. Last example, I have 3x minus 4y is less than or equal to 36. So in order to solve that, I'm going to need to subtract 3x from both sides to start with. That's going to leave me with negative 4y is less than or equal to negative 3x plus 36. To solve for y, I would divide by negative 4 on both sides. And I end up with y is greater than or equal to negative 3/4 divided by negative 4 is 3/4, positive, because we have a negative divided by a negative, so 3/4 x. Negative divided, or positive divided by a negative is going to give me a negative 9. Notice I had to flip my symbol there. When I divide by a negative, I need to make sure that I flip my inequality symbol. That rule still holds. Okay? So I've got greater than or equal to, meaning it's going to be a solid line. And because it's greater than or equal to, I'm going to be shading above. Alright, going on to the other side, we're actually going to practice graphing a couple of these. So I have the steps written here for you at the very beginning. First, it says make sure the inequality is in slope-intercept form, and I'm abbreviating that as slope form. If it's not, use your literal equation skills to make it that way by solving for y. Don't forget to flip that inequality symbol if you need to. If you divide by a negative or positive, you've got to flip that symbol. That rule still holds. All right, number 2, we're going to draw the line. So we place a point on the y-intercept, just like before. And we use the slope to create more points. Then we have to determine if the line should be solid or dashed. Step 3, we shade the graph correctly. Greater than is above the line and less than is below the line. And then I always use an ordered pair in the shaded area to test the shading to make sure that I actually did it right, because sometimes it's not necessarily apparent what is above the line and what is below the line. So if you test it with an ordered pair, you should be good to go. And I'll show you what I mean by that in a second. So if I look at this example, it's already been graphed for you. I have y is greater than negative x plus 3. So I have a y-intercept of 3, so that's the first point right there. And negative x, that's going to give me a slope of negative 1. And if you notice, it's already been graphed. Slope of negative 1 gives me the next point. This is greater than, so the shading was above. And I want to make sure that I shaded it correctly, so I can pick any point in that shaded area, plug it in here to make sure that I have actually shaded the right side. And this is just a safety net. So for example, I could choose the point 3, 3, and that's in my shaded area. So I'm going to test 3, 3 just to make sure. So I plug in 3 for y, so I have 3 is greater than. I plug in 3 for x, so negative 3 plus 3. So that's 3 is greater than... Oops, thank you. This is why it's great I have you guys with me. B should be 3. Thank you. Okay, so negative 3 plus 3 is 0. 3 is greater than 0. That checks out. It's true, so I shaded on the right side. Awesome. All right, so a couple of examples down here. The first one I have already written in slope-intercept form, which is super helpful. So let me get my b right this time. It's positive 2. So I'm going to go up to 2. And then my slope is also 2. So I put that 2 over 1. That means I go up 2 and over 1. So I'm going to go up 2 points and over 1 point to get my second. This is going to be a solid line because I have less than or equal to. So I don't need to worry about making it dashed. Solid line. And then I've got to figure out where I need to shade. So less than or equal to, I'm thinking I'm going to shade down here. So I can pick any point in that shaded area to test. If I can, I like to use the origin, the 0, 0. Makes everything really easy. It's not always on the shaded side, so I can't always use it, but if it is on the shaded side, it's the easiest one to pick. So I'm going to plug in 0 is less than or equal to 2 times 0 plus 2. I have 0 is less than or equal to 2, and I've shaded the correct side of that graph. So I can go ahead and color it a little bit darker so you can actually see the shading. I color it lightly first and then go back and shade it in darker when I see it. Make sure I have it right. Second example, not in y-intercept form, so I have to make it that way. So in order to do that, see I've got 3x minus y is less than or equal to 4. So I'm going to subtract 3x from both sides. That's going to leave me with a negative y is less than or equal to negative 3x plus 4. And I don't like that negative y. I need a positive y, so I can divide both sides by negative 1. When I divide by a negative, I have to flip, so I have y is greater than or equal to. Negative 3x divided by negative 1 is a positive 3x. 4 divided by 1 is 4, so 3x plus 4. My slope is going to be 3, and my y-intercept is 4. So I start at my y-intercept. I go up to 4. I messed it up again. Oh, negative 4. 4 divided by negative 1 is negative 4. I'm really glad I decided to record this in class today. I do love you guys. Thanks, Maddie. All right, so I have 3 and negative 4. So I'm going down to negative 4. And my slope is 3, or 3 over 1. So I'm going to go up 3, 1, 2, 3, and over 1. Again, it's going to be a solid line. I have less than or equal to. So solid line. Since it's less than or equal to, nope, greater than or equal to, man, winning today. Greater than or equal to, I think I'm going to shade above the line. So this is above it. I'm going to shade it lightly, and then I'm going to test. Nice. Origin's a test point for me again. So I can plug in 0, 0. 3 times 0 minus 0 is less than or equal to 4. That gives me 0 is less than or equal to 4. Checks out. Shade on that side. Wait. You go all the way back to your original equation for your test. So to use your, for your test, you go all the way back to the original. So you use the original. You do not have to flip the sign because you're using this original. You're just plugging in for x and y. So you plug in 0 and you plug in 0. It's a good question. You go all the way back to that original for your test point. So I'm going to use my original less than. Good call. So 0 is less than 4, and that checks out. Awesome. All right, thanks, guys.